Hello there, welcome to CXC Math TV. Today we're going to be looking at properties of matrices. And the first property of matrices we want to look at is equality of matrices. What do we mean by equality of matrices? Well, two matrices A and B are said to be equal if number one, they both are of the same order, and number two, they have equal corresponding elements. So for example, if the matrix A is ABCD and the matrix B is PQRS, then A would be equal to B if and only if the element A equal element P, element B equal element Q, element C equal element R, and element D equal element S. Now, how do we utilize this property in a question? So let's look at an example. So question 1. Given that A is negative 1 x y2, B is 2 negative 1 1 3, and C is A 10 6 B, and given A times B is equal to C, compute the unknown values x, y, A, and B. Now this looks difficult, but it's very simple. The first thing that is given is that A times B is equal to C. So we're going to start by working out A times B. So to work out A times B, we'll go first row of the first matrix times first column of the second matrix. So putting it in black, negative 1 times 2 plus x times 1. Then we'll go first row of the first matrix times second column of the second matrix. That's negative 1 times negative 1 plus x times 3. We simplify, that is 1 plus 3x. Then we'll go second row of the first matrix times first column of the second matrix. So that's y times 2 plus 2 times 1. That's 2y plus 2. And then we'll go second row of the first matrix times second column of the second matrix. So that's y times negative 1 plus 2 times 3. I'll put that in the color white. And that simplifies to be minus y plus 6. So realize AB is x minus 2, 1 plus 3x, 2y plus 2, and negative y plus 6. Now remember, they told us that A times B is equal to the matrix C. And so we're going to just put AB and equate it to matrix C. And matrix C is A, 10, 6, B. Now look at this. We're going to equate corresponding elements. Now in black, x minus 2 is in the same position as element A. So x minus 2 equal A. 1 plus 3x, we'll put it in white. That's equal to 10. We'll put that in white by equating corresponding elements. Likewise, 2y plus 2 will be equal to 6. And minus y plus 6 is equal to B. From that, we're going to have 4 equations to solve. Let's start with the 1 plus 3x equal to 10. Because by doing that, we can subtract 1 from both sides to get 3x equal 9. And we divide both sides by 3, and so x is equal to 3. Now once you get x equal to 3, we can go back to the first equation, x minus 2 equal to a. And so x minus 2 is equal to a, and x is 3. 3 minus 2 is a, and so a must be 1. Cool. Now look at the third equation, 2y plus 2 equals 6. And so we bring over the 2, and 2y equals 4. So y is equal to 2. Then finally, negative y plus 6 equal b. Y was 2, and so negative 2 plus 6 is 4, and so b equal 4. So finally, we can say that x equal 3, y equal 2, a equal 1, and b equal 4. Alright? And that is that. Easy. Nice. So that was testing equality of matrices. So here's a question for you to try. If 2a plus c is equal to a times b, compute the unknown values x and y. Pause the video and attempt. Now, in pausing and attempting, the first thing we should do is work out the left side, which is 2a plus c. That's going to be 2 times the matrix A, which is 3, 5, 1, 0, plus the matrix C, which is x negative 8, 4, y. We add corresponding elements. We know 2 times 3 is 6, so that's 6 plus x. And then 5 plus negative 8, we add that. 2 times 5 plus negative 8, that's 2. Then 2 times 1 is 2 plus 4, that is 6. 2 times 0 plus y, that is 0 plus y, which is y. So realize that 2a plus c simplifies to be 6 plus x, 2, 6, and y. Now we need to work out a times b. So we know it is row by column already, and we already looked at how to multiply matrices in other videos. So let's just work it out here without doing too many steps. So we know it's 3 times 6 plus 5 times negative 1. Then we have 3 times 4 plus 5 times negative 2. Then we have 1 times 6 plus 0 times negative 1. Then we have 1 times 4 plus 0 times negative 2. Simplifying all of those, we get a times b equals 13, 2, 6, 4. Now, remember the question said 2a plus c is equal to ab. Now, 2a plus c was the 6 plus x, 2, 6, and y. And that's equal to a times b, which we just work out to be 13, 2, 6, 4. Now, by equating corresponding elements, we see that 6 plus x equals 13. The 2 must equal 2, the 6 must equal 6, and the y must equal 4. So from equating the first element in both matrix, 6 plus x equals 13, that is telling us that x equals 7, and we have y equals 4. So x equals 7 and y equal to 4. Really nice. Nice, nice, nice. And that's how we do that question. Now the next property of matrices is that matrix addition is commutative, matrix addition is associative, and scalar multiplication is distributive over matrix addition. You must know these properties. So when you add two matrices, it doesn't matter the order, a plus b will be b plus a. Matrix addition is associative, a plus b plus c. It doesn't matter which two you add first. And scalar multiplication is distributive over matrix addition. Now, the best way they'll give you questions related to these properties is with examples. For example, given the matrix A, B, and C, we need to find A plus B, B plus A, prove that A plus B plus C is equal to A plus B plus C, and prove that 4 times A plus B is 4A plus 4B. Now let's start with part 1. A plus B, when we add them, we know we're going to add corresponding elements. 3 plus 6, which is 9. 5 plus 4, which is 9. 1 plus negative 1 is 0. And 0 plus negative 2 is negative 2. So A plus B is 9, 9, 0, negative 2, as we put in red. Now what about B plus A? So we're adding A to B. So it's going to be 6 plus 3, which is 9. 4 plus 5, which is 9. Negative 1 plus 1, which is 0. And negative 2 plus 0, which is negative 2. So notice that B plus A is also 9, 9, 0, negative 2. So A plus B is B plus A. Since we get the same results from 1 and 2, we can conclude that matrix addition is commutative. Nice. Now look at the third part. Prove that A plus B plus C is equal to A plus B plus C. Now A plus B were already worked out from the previous part of the question to be 9, 9, 0, negative 2. And now we're just adding matrix C to it. 7, negative 8, 4, 2. Now 9 plus 7 is 16. 9 minus 8 is 1. 0 plus 4 is 4. Negative 2 plus 2 is 0. So A plus B, then add C is 16, 1, 4, 0. Now let's add A plus B plus C. So we add B plus C first because that part is in bracket. 6 plus 7 is 13. 4 plus negative 8 is negative 4. Negative 1 plus 4 is 3. Negative 2 plus 2 is 0. So B plus C works out to be 13, negative 4, 3, 0. So now we have 3, 5, 1, 0, which is A plus 13, negative 4, 3, 0. Now 3 plus 13 is 16, 5 plus negative 4 is 1, 1 plus 3 is 4, and 0 plus 0 is 0. So what do we realize? A plus B plus C works out to be A plus B plus C. And so matrix addition is associative. Nice. Finally, part 4 says to prove that 4 in bracket A plus B is equal to 4A plus 4B. Now to do this proof, we start from our left hand side. We need to prove that 4 times A plus B. So we write down 4 in bracket A plus B. So A plus B, when we add those, that works out to be 9, 9, 0, negative 2. And then we multiply everything by 4. 4 times 9 is 36. So that's 36, 36, 0, negative 8. So 4 times A plus B is 36, 36, 0, negative 8. Now on the right hand side, we need to work out 4A plus 4B. So multiply the matrix A times 4 and then add it to matrix B times 4. Now 4 times 3, 5, 1, 0 is 12, 20, 4, 0. And 4 times 6, 4, negative 1, 2 is 24, 16, negative 4, negative 8. Now when we add them, 12 plus 24 is 36, 20 plus 16 is 36, 4 plus negative 4 is 0, and 0 plus negative 8 is negative 8. But notice that we get the same thing. So 4 times A plus B is equal to 4A plus 4B. This shows that the distributive law applies. And so that's it. So just what you should take away from this video is that whenever two matrices are said to be equal, they must be of the same order. And then that means they have equal corresponding elements. We need to remember that matrix addition is commutative, matrix addition is associative, and scalar multiplication is distributive over matrix addition. And so that's it for today. That's it from CXC Math TV. Stay tuned for more. Alright, make sure to have a blessed day and see you soon.